Hello, welcome to Leopard Street, or welcome back if you saw the first episode. In this episode I'll be starting the wiring. This is going to be split into a couple of parts just to manage the video length. This time I've re-recorded the audio as the quality I managed to capture on the video was absolutely terrible, and hopefully it'll make a little bit more sense with a bit of scripting. Video quality is a little bit ropey, and just as a warning, this video contains dangerous scenes of a slightly balding head and bits of a face that needed a shave. Sorry about that. This plan shows the current state of the layout track that is fixed down. There are a few more bits being used for testing, but at present this is where the layout is. As you can see, there are two circuits, each with a loop, one siding which is going to be used for DCC programming, start at the point width for the reversing loops, and the track off to the incline. In terms of the wiring, so far there is a power bus around nearly all of the layout, with just one link remaining to add when I get to that part of the board. This bus consists of a blue and brown 3202 gauge wire, which is used as the DCC bus, plus a further red, orange and black wire in 2402 gauge, which is for around the most part of the layout, providing 5 volt, 12 volt and DC ground for various things. The remainder of the layout having a 3202 white wire with 15 volt DC and the ground up rated to 3202 in those areas, this providing power to the DCC controller. Consistent colour schemes just help with wiring. So far it's working and I'm getting power where I need it to be. The brown rectangles show where the electrical panels are. Each of the layout boards has its own panel, just simplifies the electrical connections between the boards to be just the bus wires, with control over either the DCC bus for driving trains or over Wi-Fi. Solid purple box at the top is the main power box, providing the DC feeds in, and the little hash box at the bottom is the DCC controller, both of which we'll look at in future videos. So far only a very small part of this layout is powered up, with the track shown in purple. The siding in blue is also powered and can be switched to function as a normal siding or the DCC programming road via a little manual toggle switch at the end with a little printed bracket. As you can see, this isn't a particularly impressive amount of the layout is powered. This was basically wired up as the easiest bits to test the DCC control system was working and lets me program locomotives. So this week the plan is to extend this area of powered track, be undertaken in a couple of stages. This episode and probably the one following it will look at the actual wiring. Beyond that I'll go into the point motor control, which is also needed. The wiring work is going to be starting here with board E, which I've highlighted. This contains Leopard Junction, where the twin mainline tracks branch to the incline tracks that will eventually go off to a station. The goal of this task at the moment is to power up all of this track with the ability to run trains from the adjoining partly powered board onto this one, and then go round in an anti-clockwise direction, powering up the other boards as we go. This board is 7 electrical sections, partly because I'm using electrofrog points and partly to support the eventual block detection. So here we have the two tracks entering the board from the bottom, sections 1 and 2. This includes the points as well as the little lead-in section. Section 3 is a diamond, entirely as its own section so that it can form part of multiple blocks when I start looking at automation. And then the 4 run-out tracks at the top, each with their own sections. Operating plan for this board is there will no train ever be held here, so tracks 5 and 7 will have signals on the board above controlling entry. Track 2 will have a virtual signal on the board below round in the storage area, again controlling entry. Plan for this little episode is to wire these 7 blocks and the 4 frogs to the electrical panel. Frogs controlled by and connected to relays. For now the relays will not be powered, so all frogs will be configured to allow straight running of the tracks. So I can go between 1 and 5 and then 2 and 6. The diverging route will have to wait for the point motors and the associated hardware to be added. So here is board E with the suitable clutter that was on it last time removed, ready for work. This is the little electrical panel that folds down. Sorry for the shaky handheld video there. As we zoom in here, you can see the terminal bars at the top, the one on the left handling the DC power, the one on the right handling the DCC bus, and in the middle there we have a 4-channel relay board, just waiting to have the various point frogs and such connected to it. Yeah, down here in the bottom right corner, we have one of the excellent MERG, the Model Electronics Railway Group DTC8 8-channel block detection boards attached to a little 3D printed bracket. This, as the name suggests, will monitor 8 blocks for current detection, so DCC only. Eventually this will be connected to a microcontroller. Short term, I'm just going to be wiring the power through this board. It'll sit unpowered passively in the connection. Yeah, and here we have some of the little wires just dangling down from underneath the track, looking all so innocent currently. Little do they know what lies in their future, as some of the bolts that secure things. This is the bus connector that goes between the boards. It's very easily removed, as that, and that is literally that side. This side, yeah, is a little bit more awkward to get to, but that's that. And this is now that board completely isolated electrically. Yeah, so right, with the electrics disconnected, we now have the unenviable task of removing the 5 M8 bolts that secure this board. There's 3 on one side and there's 2 over here, one of which is under the little scenic area at the front. Camera is now on a tripod, so hopefully it won't move around quite so much in the future. Unfortunately, this does mean you get to see me. Here we are securing the electrical board. Yeah, sorry about the bald head. It's a family thing. Literally M8 wing nuts on bolts with a couple of washers through holes drilled in the board. There's nothing fancier than that with the alignment. The idea here is these boards will be dismantled every now and again. This is not a particularly transportable layout. So that's the first bolt out, and here you can see this is literally all it is. Wait for myself to show this. Here we are. Look at that, the miracle of modern technology. Removes a bolt, so there we go. Get back underneath. This second one is slightly more awkward to get to. And as you can see, I do need a shave in this video. I will have to learn on that. There you go, see, smile. Always smile for the camera. As this bolt comes out as well. And then obviously there's some more at the other side to remove as well. And here we are back over to the other side, removing the 3 bolts that are over here. It would have been just 2 bolts, but with the slightly raised section there, it made sense to stick an extra hole in there. And again, these come out. Access is a little bit awkward to these. Eventually, these will all be concealed from the front. But like I say, this isn't something I plan to do particularly often. And here we come with this one. You wouldn't have thought somebody could struggle so much with 3 bolts, but I have seemed to manage it fairly regularly. But there we go. Yeah, there's another bolt suitably removed. I'll just stick the nuts and the washers back on, because otherwise I will lose them. This seller eats miscellaneous little nuts and bolts. It's worth noting these modules are not particularly heavy. This is, as noted previously, 9mm ply framing. There's a little bit of strip wood in here with a 6mm ply deck. The whole point has been made to make these things relatively simple to move around, because this is just me moving these things. This last bolt is incidentally the only thing that actually holds the board on this side. So this is now completely free, just held in with a little bit of copied X on this side, which we can then remove. And as we see, it came free. This was the first time I've actually dismantled this board since it's had track laid on it. So there was a level of nerves here, as we're trying to just make sure where it's actually sticking slightly. And it comes free. There we go. As you can see, that move up and can just be rocked backwards slightly and then lifted clear. So here we go. One thing I may have to consider on this is better ways of manipulating these boards, as this is not easy. And apologies for that, you're seeing more of me than you are of the layout here. So here we are. Board just goes down nicely onto its side, ready to be worked on. Yeah, okay, so this is the board now sitting on a workbench. There's a clamp around the back so it's not going to fall over. So you can see what we're doing here. All the various little tracks at the top ends. The red dots mark where the insulated rail joiners are. The blue dots are where the power feeds are. suitably numbered, just so that I can try and get my head straight about what they are. And there was a lot more waffle here, but I may as well cut most of this out. As you can see here, we've got some bits of the track are painted. This will eventually be a scenic section. That's quite a way off. So I'll leave this fool pointing at stuff, and we shall move on. Yeah, so here we are with the reverse of the board. You can see the electrical panel there, and the various underside pieces of wiring. There's nothing fancy here. The wires just literally come straight through drilled holes. The panels over here, 3 foot by 2 foot main module. I think the panel's about 2 foot long. There's the little catch that holds it. As you can see, there's nothing fancy there at all. I was going to use bolts and magnets, but that just didn't work. There's your power bus connector down at the bottom end. There's just a simple plug and socket screw terminal. This board has the white wire, although this board doesn't interact with the white wire in any way, shape or form. That just moves from one side to the other. The other 5 wires going up to the electrical panel. And yeah, we'll stop looking at that shortly. There's a little bit of tape, goes up here, runs around as the other connector at the other end. So literally the board can be powered from either side. Idea there being I can power them up individually. And here's all the little rat's nest of unlabelled wires that sits underneath the thing. So yeah, let's get on with trying to wire this up. So we're going to start with sections at the top, which is sections 5, 6 and 7. As you can see, each one has 2 wires, one blue, one brown. And these are not long enough to go to the full length of the electrical board. I blame incompetence for this. So what we're going to do here is stick a small electrical connector block to the underside of the board near the feeds, under the rails, ideally, so that we don't end up drilling holes through into it later. And then we can connect everything in. So I'm using these little terminal blocks, which will eventually come into view, which just bought off Amazon. It's basically a bus terminal. You can stick in a bus rail across the top and then make them all common, or do what I'm going to be doing here, which is having the 3 on the left with a little common connector, and all the blue wires will go into those, and the brown wires will go into the ones on the right individually, which will be done with the aid of a few small screw terminals. However, firstly we get to watch this clown trying and completely failing to fit this connector block to the board. This screw in normally. This is fairly thin plywood. The benefit here is there is 5mm XPS foam and then 2mm of cork on the other side. So here we go. This is demonstrating why you use pilot holes. As you can see, this is not cooperating in the least. Here we go. Just goes round and round, round and round, sideways. Doesn't bite. Goes sideways again. So we give up on that. So yes, here we have the solution. As you can see, I'm a big fan of power tools. 2 very small pilot holes. They're actually probably too wide as 3mm, but I'm only just literally biting into the plywood slightly. This will let the screws go in. This is sort of a key learning point for the future. Remember to use a pilot hole. But there we go. And here we can see if I'd have done this in the first place, this would have worked quite nicely. So in this goes slightly, just making sure the screwdriver is actually biting it correctly. Goes in, just goes in about halfway, making so I can work out where the other hole needs to be, get that marked out, and then get that one drilled in as well. As you can see here, it's dedicated craftsmanship. There's remarkably little in the way of accurate measurements that have been used in this project. This is all very rough and ready. And you wouldn't have thought it would take quite this long to get this far into a video, and so far you've seen one screw going into a piece of plywood. Well, here comes the second one, so we've doubled the amount of work we've done. That lines up roughly, and in it goes. Look at that, nice and wonderful. Tighten up the first one, and that's now mounted. Now this layout makes use of a lot of these little boards, but there we go. And at this point I'm just about running out of time for this video, so join in next time.